Hello everyone, welcome to my channel on learning field. Today in this topic I'll teach you what is electric field and what is electric field. So electric field means the space around a test charge in which it experiences a force. When a test charge Q is placed near a source charge Q, then the electrostatic force F will act on the test charge. That means that suppose I have taken the example here. Suppose the example here is taken. Suppose this is the electric field. Here it is given mentioned that electric field lines. Suppose it is the electric field. The space around it experiences a force. Suppose when a test charge q is placed near a source charge q, then the electrostatic force, that is electrostatic force F will act on the test charge. Do you understand? The next topic is what is electric field lines. That means electric field lines means these are the electric field lines, isn't it? These are the electric field lines. Suppose plus q charge, minus q charge, these are the electric field lines. And the next topic now is what is electric field intensity. Electric field intensity means it is denoted by E. We all know that. And electric field intensity at a point in its electric field is defined. That means it is defined as the force experienced by unit positive charge kept at that place. That means kept at that point. We can write the expression as E is equals to F by Q. That means F is force, Q is charge. Electric field intensity is a vector quantity. Remember that. Electric field intensity is a vector quantity. Remember that. It is very important notes I have shared you all. Please share and subscribe my channel. Don't forget to share and subscribe my channel. Okay. The next topic is superposition principle. Now what is superposition principle? Superposition principle states that superposition means more than one Coulombian force. That means more than one Coulombian force. It states that when more than one Coulombian force acting on it is equal to the vector sum of the individual forces. That means we can understand this by proving the principle. Let us prove the principle. Let us consider that let q1, q2, q3 and q0 be the point charges with their respective q1, q2, q3 are applying forces F01, then F02, then F03 respectively on the charge q0. Then according to superposition principle, what we can write that according to superposition principle, total force F will be equals to F01 plus F02 plus F03 dot F0, and this is the vector. Okay. The next what we can write is that force will be equals to this one F01, F02 plus F03 dot F0n. If we'll add, then we'll get like this: Q1 by 4 pi epsilon naught into sum over n I is equals to 2 qi by r1I square into r1I cap. This is the required solution. Now the next topic is electric field lines. Electric fields, that means electric field lines. Now electric field E at some point in space, is defined as the force experienced by an imaginary point charge of 1 coulomb divided by 1 coulomb. That means 1 coulomb divided by 1 newton, that means 1 newton divided by 1 coulomb. That means we can write F is equals to previously we have written that E is equals to F by Q, isn't it? E is equals to F by Q. That means electric field we can write E is equals to F by Q. We measured the electric field using small test charge. We measured by small test charge. Small test charge, that means it is denoted by BQ, and dividing the measured force by magnitude of the charge. Remember that. The next topic is electric field lines. Electric field lines. What are electric field lines? Now electric field lines means the line of force may be defined as a curved tangent at any point of which the direction of the electric field intensity at that point. Electric field lines, you can note down that electric field lines means the lines. These are the lines, isn't it? It is denoted by arrow. These are the electric field lines. Suppose a charge is plus Q, the electric field lines for this is it is denoted by the rows. These are the electric field lines. And what are the important properties of electric field lines? You need to note down these important properties. It may come in exam. So the line of force are directed away from the positive charge towards the negative charge. That means the line of force are directed from positive towards the negative charge. They are directed from positive terminal to the negative terminal. Now the next point is two lines of force never intersect each other. That means suppose this is a electric field lines, isn't it? Now these two lines never intersect each other. If they intersect, that means they are not electric field lines. A perpendicular will be drawn from here. That means it is not possible. Okay. The next point is the number of lines per unit area is proportional to the magnitude of E. That means the number of lines, how much the number of lines is proportional, is directly proportional the magnitude of E, the magnitude of electric field lines. Okay. Now the next point is the lines of force never pass through the conductor. That means you will came to know that the line of force never pass through the conductor. Now the next point is the line of force tend to contract lengthwise or longitudinally. You can look here. This is minus Q1 charge and this one is plus Q1 charge. They never intersect each other, isn't it? They are contract lengthwise or longitudinally. This one also we can see it clearly here. Then the next point is the line of force tends to exert lateral pressure or vice versa. That means they tend to exert lateral pressure. You'll came to know about the topic later on. Now the next point is electric field due to a system of charges. We'll prove this principle. For this we need to consider a system of charges Q1, Q2 and Q3 Qn with position vectors r1, r2, r3 Rn with origin O. Here they are considered with origin O. Then electric field E1 at R due to Q1 at R1 will be equals to, they are the position vectors of R2P, R1P, R3P, R4P, these are the position vectors, isn't it? Therefore the electric field will be equals to 1 by 4 pi epsilon naught into Q1 by R1P square. We have the formula of electric field lines already, isn't it? Then R1P whole cap. Similarly E2, for E1 we have done, for E2 will be, E2 is equals to, this one will be same and here will be R2P cap. Similarly, if therefore E to the power n, then what we can do is that it will be sum over. This is the required principle, and this is the electric field due to a system of charges, due to many charges and position vectors. is the required answer. Now let us review on Coulomb's law and electric field definition. We know that Coulomb's law is the force between 2 point charges, isn't it? F12 is equals to Ke Q1 into Q2 by R square F12, isn't it? And is equals to 1 by 4 pi epsilon naught into Q1 into Q2 by R square into R12. We have already studied this one, isn't it? And we know that K is equals to 8.9876 into 10 to the power 9 Newton meter square per Coulomb square, isn't it? This is very important point, isn't it? And epsilon naught is equals to 8.854 into 2 into 10 to the power minus 12 Coulomb square per Newton meter square, isn't it? And we know that the electric field lines is defined as electric field is equals to F by Q, that is test charge. Remember that electric field lines is equals to F by Q test charge, force per unit charge, that is test charge. Okay, the next point is the force a charge experiences in an electric field is equals to, that means it is the reversible. If we cross multiply this one, then force will come, isn't it? So force will equals to charge into electric field. Remember this one, you need to note down. The next point is electric dipole. Now what is electric dipole? Electric means already we know electric, and dipole means having two poles, dipole, di means what? Di means two, and pole mean already pole. And dipole, an electric dipole consists of a combination of two equal and opposite charges. These are equal, plus q and minus q, situated very close to each other. They are situated very close to each other with a center of origin having O. A and B, they are the point, and plus q and minus q are the charges, and this is known as the axial line. This line is known as the equivalent line. Remember that an electric dipole consists of a combination means they always consists of a combination of two equal and opposite charges. There should be two equal and opposite charges. Suppose this is plus q, there should be minus q. Opposite charges situated very close to each other, they should be situated very close to each other. Okay, this is meant by electric dipole definition. And the next topic is, now what is electric dipole moment? Electric means already we know, electric means what? Flow of electrons, isn't it? Now dipole means what? Di means two and pole means two poles, having two poles, and movement means having a that means it is separation between, we can define is, it is defined as the product of the magnitude of each charge and the separation between them. It is denoted as P. Electric dipole moment means what? P is equals to Q twice D. You can write like this also. You can define by looking at the formula also. Electric dipole moment is defined as the product of the magnitude of each charge and the separation between them. Since it is dipole, that's why it is written here 2D. And electric dipole moment means those quantity which have both direction and magnitude, they are known as vector quantity, isn't it? We have learned already. And scalar quantity means those have magnitude but no direction are known as scalar quantity, and its direction is along the axis of the dipole. That means the electric dipole moment is along the axis of the dipole. Its direction is along the axis. Suppose this is the axis, isn't it? This is the axis, its direction is along the axis. And the next topic is, we'll learn how to prove this topic, electric field due to an electric dipole at a point on the axial line. Please don't forget to subscribe and share my channel so that I have my motivation from you. Thank you, you all.